Hi, today we're looking at Functional Skills Maths Level 1. We've got the Highfield exam board, and this is the second sample paper, and we're going to look at the non-calculator section first. Okay, so question 1. Write these fractions in order from smallest to largest. Okay, so we're going to do this by getting our denominators the same. Okay, so we've got 1/2, so over 2, 7 over 8, 3 over 4, and 2 over 8. But because we've already got 2 over 8, and I know that 2 goes into 8 and 4 goes into 8, I'm going to say, well, let's keep 7/8. We'll keep that unchanged, and we're going to keep 2/8 unchanged as well. But what I want to do is I want to rewrite 1/2 as being something over 8. Okay, and I know I can do that because I know that 2 goes into 8. Well, how many times does 2 go into 8? Well, 2, 4, 6, 8. That's 4 times. So multiply the 1 by 4. So this is the 1. It's 4 times to give us 4. So hopefully you can see that we've got 4/8, which is the same or equivalent to 1/2. But because it's over 8, it's going to make it easier to do our comparison. So I can do the same with this because 3/4, I know 4 goes into 8. So we can rewrite this fraction as being over 8. This time we're saying, well, how did we get from 4 to 8? Well, 4/8, that was only twice. We were just doubling this. So we need to do the same to the 3. So it's going to be 3 doubling it, or times 2, and that's going to give us 6. So we've now got our 4 fractions, but with 2 of them rewritten so that they're over 8. So we can ignore the denominators because they're all the same, and we can just say, well, let's compare the numerators. Which is the smallest numerator? Well, the smallest number out of 4, 7, 6 and 2 is 2. So the first fraction is going to be 2/8. Then what's the next? So we can cross that one off. What's the next smallest? Well, then it's the 4. So 4/8. So we could write 4/8, but actually the 4/8 replaced the half. So we can put the original half back in. And we've used that one. Now 6 is smaller than 7, so 6/8 will go next. But again, 6/8 replaced 3/4. Because they're equivalent, so we can put the original back, and that just leaves us with 7/8. Okay, so they might look a little bit odd here, but we know that actually a half is equivalent to 4/8 and 3/4 is equivalent to 6/8, so it all makes sense. Okay. Question 2. Work out the value of 15 with little 2, which means 15 squared. And hopefully you'll remember that 15 squared means 15 times 15. Okay, 15 times itself. So we're going to do this using the column method. Other methods are allowed as well. So we're going to say, what's 5 times 5? We've got 5, 10, 15, 20, 25. So put the 5 and carry the 2. And then we've got 1 times 5, which is 5, plus the 2, which is 7. Okay, so now we move on to the 10s. So we can put a 0 down here. So we say 1 times 5 is 5, and 1 times 1 is 1. And we need to add these together now. So 5 plus 0 is 5, 7 plus 5 is 12, so 2 carry the 1, and 1 plus 1 is 2. So there's our answer. And question 3. So we've got 8 plus 8 times 8 minus 8. So the real key thing here is to remember your BIDMAS rules and which order we need to do these. Well, with BIDMAS, we start with the B for brackets. Well, we've got no brackets. The I is for indices, or you might know it as BODMAS, so the O is the order of. We haven't got either of those. Then D for division. Well, we haven't got any division. M for multiplication. Now, yes, we have got some multiplication. We've got 8 times 8. So we're going to work this out first. So 8 times 8, we've got 8, 16, 24, 32, 40, 48, 56, 64. Okay. Now, although we worked that out first, everything else stays in the same position because we haven't done anything with those yet. Okay, so we've got the 8 plus before it and the minus 8 after it. Okay, so when it's BIDMAS, although the addition comes before the subtraction, we would just do it in order from left to right. So we can do our 8 plus 64 and work that out, and then take off the 8. Now, you can do that, and I can do 64 plus 8, work it out. So that would give me 4 plus 8 is 12. Carry the 1, and then 6 plus 1 is 7, so we get 72. But then we'd need to take off the 8 again. So 72 minus 8. We'd say 2 minus 8 we can't do, so reduce it to a 6. That becomes 12. So we say 12 minus 8 is 4, and 6 minus nothing is 6. So you'll see we end up back with the 64 that we started with. So instead of doing these two calculations, we could just say, well, we're adding 8, and then we're taking off 8. So the answer is just going to stay as 64. Question 4. Which of these nets can be folded to form a cube? Right. So hopefully you've done some of these nets before. If you haven't, don't worry, we can still work it out. But the good place to start with is to think, well, what does a cube look like? Okay. Well, a cube, if you think of it like a dice. So that's my cube when it's all folded up. And like I said, it's like a dice. Well, how many sides has a dice got? Well, a dice has got 6 sides. If I try and draw that down. It's got the front, back, the left side, the right side, the top and the bottom. Okay, so the net is going to need to have 6 faces. So straight away I can see we've got 1, 2, 3, 4, 5. So that can't make a cube because it's too many. Not enough. If we look over here, we've got 1, 2, 3, 4, 5, 6, 7. That's too many faces, so that can't make a cube. So we've got 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So it's going to be one of these two. They've at least got the right number of faces. Now, if you think to make a cube, we've kind of got these 4 that wrap round, and then we've got a top and the bottom. Now we'd see here, we've got the 4 to wrap round, but then we've got this extra one stuck on. So that's not going to work. Whereas with D, if we wrap this round, we'd have 1, 2, 3, 4. So that would be my 4 going around the outside. And then we can fold 1 over for the top, 1 under for the bottom. So that's going to be our correct one. Okay. But like I showed with the others, although this is a correct one, we actually worked it out by showing which ones wouldn't work. So almost a process of elimination. Question 5. You want to buy a new surfboard. You have found a surfboard that is on special offer. So we've got Pro Board. List price £235. Special offer 12% discount off the list price. How much will a surfboard cost after the discount? Show your working out and write the answer in the box below. Right, 12% discount. So that means we need to take 12% off of this figure. Okay, now remember we're in the non-calculator section. So we do want to work out 12% of 235, but without a calculator, well, you could do 12 divided by 100 times 235 and work it out that way. But I like to think of it differently. I like to try and simplify things. So what we can think of 12, I'm going to think of 12, or in fact 12%, as 10% plus 1% plus 1%. Oh, sorry, 12% equals 10 plus 1 plus 1. Okay, agree this makes 12. And the reason I've done that is because I know that 10% of 235, well, I can just move my decimal point in one. So it's just going to be 23.5. And if I want 1% of this, well, I'm going to move the decimal point one place further. So 1% of 235 is going to be 2.35. And because we need another 1%, in fact, let me show down here that we're going to have 23.5 for our 10%. Then for our 1%, we're going to have our 2.35. And remember, we said we need two 1%. So we're going to have another 1%, which is another 2.35. So if we add these all together, we will find the value of 12%. Now, when you're adding, it's always good to have numbers in, even though in this case it's going to be a 0. It just means that we've got something to add up, and we don't kind of make mistakes by having things missing or blanks. It can be confusing. So we're going to add these up here. So 0 plus 5 is 5, plus another 5 is 10. So carry the 1. So 5 plus 3 is 8, plus another 3 is 11, plus the 1, we've got 12. Bring our decimal point down. 3 plus 2 is 5, add 2 is 7, add 1 is 8, and 2 plus nothing is just a 2. I don't tend to put zeros here because that just feels a bit more normal, whereas when we have decimal places, it's nice to have the same number of decimal places, so that's why I put the 0 in there. Okay, so we've got that 12% is equal to £28.20. Now, it's a discount, so we need to take that off. So we've got our original £235. We want to take off £28.20. So again, so we've got something to take this number from. I'm going to put 0.00 in here. So now we have 0 minus 0, 0. 0 minus 2, well, we can't take 2 away from nothing. So we'll reduce our 5 to a 4 and give 1 there to make it 10. So 10 minus 2 is 8. Bring down the decimal point. 4 minus 8, again, 8's bigger than 4, so let's reduce that to a 2 and give 1 over to the 4 to make it 14. 14 minus 8 is 6. 2 minus 2 is 0. 2 minus nothing is 2. So we've got our final answer there. I'll rewrite it. It's £206.80p. So we've got question 6. You're preparing to enter a local surfing competition. You know that it will take you 45 minutes to drive to the competition, 11 minutes to put on your wetsuit, and 25 minutes to register for the competition. The competition starts at 1 p.m. You start the above activities at 11:30 a.m. Will you be ready in time for the competition to start at 1 p.m? Show your working out and write the answer in the box below. So there's two main ways you could do this. You could start with 11:30 and then add on each of these times as you go. Or the way I'm going to do it is I'm actually going to add all of these numbers together to start with and then add that whole total onto 11:30 and see whether we get up to 1 p.m. So, well, 5 and 1 and 5, but I can see 5 plus 5 makes 10. Plus 1 is 11. Carry the 1. 4 plus 1 is 5. Plus 2 is 7. Plus 1 is 8. So we've got a total of 81 minutes. Okay, well, if we're going to start at 11:30, let's go up to, well, let's think, to get up to the next hour, to get up to 12 o'clock, well, it's half an hour, isn't it? 11:30. So we're going to be adding on 30 minutes. So if we've already used up 30 minutes, we had 81 minutes, we've used up 30. So 1 minus 0 is 1, 8 minus 3 is 5. So 30 minutes took us up to 12 o'clock. We've still got an extra 51 minutes to use, so we can just add on that 51 minutes. So see, this is nice and straightforward. 0 plus 1 is going to be 1. 0 plus 5 is 5. And nothing's changed. So we've got a total time of 12:51, and that's in the afternoon. Well, that's before 1 p.m. So, yes, you will be ready in time. Question 7. You volunteer at the Highfield Nature Reserve. There are a total of 10 volunteers at the reserve. Every day a name is drawn at random to see who will refill the bird feeders. On the scale below, mark an X to indicate the probability that you will be drawn to refill the bird feeders on a single day. Okay, so we need to mark it on here. I'm actually going to work out the probability first of all, because I think that's easier. So if there's 10 volunteers, we want the probability that you will be drawn at random, so that's one person, so the probability is going to be 1 out of 10. Now, what have we got on here? So probabilities always go from 0 up to 1. So if it's 1 out of 10, let's see how many sections we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 out of 10 is just going to be one section. So it's going to be there. So you can think, if you want to think of it as a decimal, it's going to be 0.1, 1/10. Question 8. Last year, the reserve received £3,700 in donations. This year has seen a 15% increase in the amount donated. How much has been donated this year? Show your working out and write the answer in the box below. Okay, so this is similar to what we had before. So with percentages, we're going to think, well, 100% is 3,700. If I want 15%, I'm going to think, well, 15%, that's going to be 10% plus 5%. So for 10%, that's nice and easy. I can just take a 0 off. So that's going to leave me with £370. 5%, well, 5 is half of 10. So 5% is going to be half of 370. So we want 370 divided by 2. So if we do this with the bus stop method, we can say how many times does 2 go into 3? Well, it goes once with 1 left over. What about 2 into 17? Well, 2, 4, 6, 8, 10, 12, 14, 16. So that's 8 times. And 1 more would take it up to 17. So that's remainder 1. What about 2's into 10? 2, 4, 6, 8, 10. That's 5 times. Okay, so if 10% is 370, 5% is half of that, which we've just worked out is 185. Now we're increasing the amount by the 15%, so that means we just want to add all of these together. 0 plus 0 plus 5 is 5. 0 plus 7 plus 8 is 15. 7 plus 3 is 10, plus 1 is 11, plus 1 is 12. And 3 plus 1 is 4. So we got a total, and I'll put it down here, 4,255. So I haven't been writing all of my answers in the answer box. Obviously you would each time, but I haven't because we're just doing it for the video. But yeah, always write your answers in the answer box. Okay, we're on to question 9 now. Let's see if we can fit that on here. You are preparing a presentation on the different types of birds in the reserve. You display the figures in a chart. And we've got the chart here to show number of birds in the reserve. This is a pie chart we've got here. So we've got owls, we can see are the most popular. Then we've got woodpeckers and turtle doves. Let's move this down. So we're told that 1/5 of the birds are woodpeckers. So that's this section here. 70% of the birds are owls. That's here. The remainder of the birds are turtle doves. Calculate the angles to complete the table below. Right, okay. So we've got the type of bird, we've got woodpeckers, and we've got the angle in the pie chart. Right. Well, we've got 1/5 of the birds are woodpeckers. Excuse me. Well, if we're talking about angles, I know that the total number of angles in a circle are 360 degrees. So if 1/5 of them are woodpeckers, then we want 1/5 of 360. Or in other words, 360 divided by 5. So we'll do this with the bus stop method. Does 5 go into 3? No, because it's bigger than 3. What about 5 into 36? Well, we've got 5, 10, 15, 20, 25, 30, 35. 40 would be too many, so we stop at 35, which was 7. And one more to take us up to 36. Then we say, how many times does 5 go into 10? 5, 10, that's 2. Okay, so we know that the angle for woodpeckers is 72 degrees. Now, we've got 70% of the birds are owls. Well, again, if we think the total number of angles are 360 degrees, so what we're saying is 70% of 360. That's what we want to work out. Okay, so different ways we can do this. So we can start by thinking our sort of like 10% each time. What I'm going to do instead, just to do a different method, I'm going to say, well, 70% would be 70 out of 100. And it's of 360, so it's times 360. Okay. Now we can do a bit of cancelling, because we're sort of on our fraction. Well, if we think just of the fraction to start with, we know that if we got a 0 and a 0, one on top, one on the bottom, it's like we can divide top and bottom by 10. So in other words, we can cancel those. Now over here, we can say, well, we're dividing by 10, but we've also got a 0 on the end here, so we're like multiplying by 10, so we can cancel that 0 with that 0. So we end up with 7 divided by 1, which is just 7, times 36. Or in other words, 7 times 36, like that. Well, let's do 7 times 6. So 7 sixes, so 6, 12, 18, 24, 30, 36, 42. So 2 and carry the 4. Then we've got 7 times 3, or 3 times 7. 7, 14, 21. Add the 4, gives us 25. So for owls, we've got 252 degrees. Now turtle doves must be the rest. So what we can do is add these two together. 252 plus 72. So 2 plus 2 is 4. 5 plus 7 is 12. 2 carry the 1. 2 plus 1 is 3. So we've got a total of 324 degrees there. We said we want to take that away from 360. So 0 minus 4 we can't do, so we reduce the 6 to a 5. Now 10 minus 4 we can do, that gives us 6. 5 minus 2 gives us 3. 3 minus 3 is 0. So we get an answer of 36 degrees. And that's the end of the non-calculator section. So now let's have a look at the calculator section. Question 1. K equals 4y all divided by x. Calculate the value of k when y equals 17.4 and x equals 12. Right, so we've got a bit of algebraic notation, but that doesn't matter, we know how to deal with this. So when we've got a number next to a letter, there's an invisible times in there. So this is equal to 4 times, and the y they've told us is 17.4. So we can put that in. And then that's all divided by x, which we now know is 12. So let's bring in our calculator. So we want to do, let's move it down here so we can see 4 times 17.4. So we can put that in. So the top becomes 69.6. And that still all needs to be divided by 12. Now, you'll note I did the multiplication before the division. Now, you might be saying with BIDMAS, D comes before M. But because we've got this all on top, it's like there's an invisible set of brackets up here. Because it's all of this is divided by 12, so we have to do all of that first. But now we can do the 69.6 divided by 12 to give us 5.8. Okay, question 2. Work out 783.48 divided by 100. Write your answer correct to 3 decimal places in the box below. Okay, well, if we're dividing by 100, we could move the decimal point 1, 2 like that. But you don't have to do it that way because we're in the calculator section. So you could just type it all in, divide it by 100. Right, so we get our answer. We want it correct to 3 decimal places. So we've got 7.8348. So at the moment that's 1, 2, 3, 4 decimal places. We want 3, but we need to look at this number, this last digit, because we want 3 decimal places, so we look at the 4th digit and say, well, is that going to impact what we've got? If it's less than 5, it won't. This will stay the same. If it's 5 or more, then we will need to increase the previous digit by 1. And in fact, it is 5 or more, it's 8. So this is going to become 7.835. Question 3. You are using a map with the following information displayed. So we've got miles on here, and we've got that 2 inches equals 10 miles. On the map, your home is 7 inches away from your workplace. So that's on the map, not in real life. That wouldn't be very far. What's the actual distance between your home and your workplace? Show your working out and write the answer in the box below. Right, so we've got 7 inches here. We know 2 inches is 10 miles. So what we can say is, well, how many times bigger is the 7 inches? So in other words, we can say, well, 7 divided by 2. What does that give us? Well, 7 divided by 2 is 3.5. So it's saying it's 3.5 or 3.5 times bigger than the 2 inches. Well, if the 2 inches represented 10 miles, well, then we want to do 3.5 times 10. which gives us 35. And now we're in miles. Okay. A different way you could think of it is, well, if 2 inches are 10 miles, well, then let's half it. 1 inch would be half of 10, which is 5 miles. If we want 7 inches, well, we're going to want 7 times 5, which is still going to give us 35 miles. So that might actually be a nicer way to think of it. Okay, question 4. Draw the line or lines of symmetry on this isosceles triangle. Well, I know that if it's an isosceles triangle, that means that 2 of the sides and 2 of the angles are the same. And it looks like it's these 2 angles which are the same. So that tells me that we're only going to have one line of symmetry here, and that's going to be straight down the middle. If you want to be completely accurate, you could measure this line here, work out halfway and put it in, but I've done it by sight and I think I'm pretty close there. Okay. They wouldn't necessarily expect you to calculate it accurately, so long as it looks reasonable, which that does. Okay, we're not going to have a line of symmetry over here because it's not going to match. Remember, with line of symmetry, it means if you fold the shape together, you'd get a perfect match. Okay, question 5. Calculate 7/12 of 1080. Okay, well, we can do that on our calculator. Now, what you find, we can do it 7 divided by 12 times 1080. If you're using a simple calculator like this, then it will give you a slightly odd answer that you're then going to need to round. So 629.9999. So we would need to round that up to 630 kilometers. Now, one way to avoid this is to say, well, 7/12 of this is like 7 times the top number. So 7 times 1080, and then divided by 12. So you get the 630. So it's this dividing that's given us the decimal, which has then gone a bit funny, and we've had to do some rounding. Okay, so you're only going to get that with a simple calculator, but I would say just reverse it. Or in fact, if you just put it around the other way. So this is telling us it's 7/12 times 1080. Think of it as 1080 times 7/12. And then if we type this in, 1080 times 7 divided by 12, again we get 630 without the rounding problem. Question 6. Calculate 7.26 divided by 24.2. Write the answer in the box below. Well, we've got our calculator again, so this shouldn't be a problem for us. You just type it in exactly as you see it. 0.3. Question 7. There are 600,000 people living in Coventry and Wolverhampton combined. The populations are split in the ratio 7:5. How many people live in Wolverhampton? Show your working out and write the answer in the box below. So the first thing we're going to do is convert this number from words into digits. So we've got 600, so 600,000. Okay, so that'll get you a mark. Even if you're not sure how to do the question, just by writing that, you've scored 1 mark. And now, because it's a ratio question, they've even told us it's ratio, I'm going to draw a little table. If you're comfortable with ratios, fine. If you're not comfortable, doesn't matter. Still draw a ratio table. Okay, so the ratio we're looking at is the ratio between Coventry and Wolverhampton. And we're going to have a column for a total. So the ratio is 7 to 5. Now, if that's all we had, then the total would be 7 plus 5, which is 12. In fact, what they're telling us is the total is actually 600,000. So when we're doing these ratio tables, we're trying to find the column that's got 2 digits in, because this is going to help us to update these numbers. So we want to know, how do we get from 12 to 600,000? Or think of it backwards. Think 600,000 divided by 12. And we get 50,000. So what that's saying is to get from 12 up to 600,000, we're multiplying by 50,000. So we just need to do the same for these two numbers here. We'll multiply that by 50,000 and we'll multiply the 5 by 50,000. So 50,000 times 7 gives us 350,000. And 50,000 times 5 gives us 250,000. Okay, they've just asked how many people live in Wolverhampton, so they just want this number here. But I like to work out all of the numbers on the new column, because also, sorry, on the new row, because you can do a check then as well. Because we can say, well, if we've got 250,000 plus 350,000, that should give us this answer here, which it does. So we know that we've done it correctly. Okay, question 8. You work at Highfield Castle. As part of your job, you walk round the perimeter of the castle to perform security checks. Below is a diagram of the castle. The main section and each of the turrets are squares. So big square in the middle and then 3 turrets here. Okay. And the question's just down here. How far do you walk on each security check? Give your answer in meters. Okay, so they've said give your answer in meters. We've got meters on here, but note that one of the measurements they gave is in kilometers. Okay, so the first thing I'm going to do is convert this into meters. So I know that 1,000 meters is 1 kilometer. So if I want to convert this into meters, I'm going to multiply it by 1,000. So 0.124 times 1,000, and we're going to get that's 124 meters. Okay, so that's just going to make life easier. We can forget about the kilometers bit now, just use 124 meters. So we're going to be walking all the way around the castle. Okay, so basically what we need to do is to work out what the perimeter of the castle is. Okay. Well, they've given us some of the measurements. So they've told us that this is 0.124 kilometres or 124 metres. Well, because this is a square, it means over this side, this is going to be the same. That's also going to be 124 metres. Okay. And if we think about the turrets, well, if it's 12 metres along here, I'll draw it on the inside. That's going to be 12 metres as well. In fact, wherever we've got a full sort of outside of a turret, it's going to be 12 metres. So another one here. Another one here. So you'll see that what we're trying to do is get a measurement for each of the lengths. So every single straight line going around the outside, we want a measurement in there. Okay, so we've got our 12s, we've got 124s. We've got these short bits here, which they look like they're half a turret, and in fact it tells us that that's 6 metres. Okay, so if we've got 6 metres here, well, that's going to be 6 metres. That's going to be 6 metres. We've got another one here, another 6 metres, another one here, 6 metres, another one here, 6 metres. So actually, if we're going around, we've got measurements for all of these, apart from these two straights here. Okay, so we're going to need to work this out. We know that, in fact, if I draw it down here, we know that from there to there would be 124 metres. I'll just write it lightly. We want the distance all the way to the end. Well, we know that this is half a turret, so 6 metres is half of the 12, so this must be another 6 metres here. So that must be 6 metres. So that means that this distance all the way along is going to be 124 plus 6, which is 130 metres. And that's going to be the same for over here. Okay, so we just need to add all of those together. Okay, in fact, I'll just do it. It's always good if you're going to be doing that and working them out, it's good to pick a corner. So I'm going to kind of mark that because I'm going to put, that's my start point. Doesn't matter where it is, it's just so I don't forget and double count or miss anything out. So if I'm starting here and I'm going to walk clockwise, so we're going to have 130 metres. Then I'm going to come down and walk 6 metres. Let's put it here so we can see it. Okay, so I've done 130 metres, then I've walked 6 metres. Then I'm going to walk 12 metres across here, then 12 metres up, then 6 metres across, then 124 metres up to here, then 6 metres across, then 12 metres up, another 12 across, 6 metres down, 124 metres all the way along, 6 metres up, 12 metres across, 12 metres down, 6 metres across, and then 130 metres all the way back to the starting point, which gives me a total of 616 metres. So I'll put okay. So that's the best way to do it. Work out all the measurements first and add it up. If you find it confusing adding them all up as you go, because it's a lot to add up, what you can think of instead is think of, well, what are the different measurements I've got? Well, I've got 124, and how many of those have I got? Well, I've got 2. I've got 1, 2. Then I've got 130 metres, and I've got 1, 2 of those. Then we've got some of these 6 metres, and we've got 1, 2, 3, 4, 5, 6. So we've got 6 times 6, and then we've got some 12 metres as well. And we've got 1, 2, 3, 4, 5, 6. So if we work out all of these totals, in fact, let's do that right now. So 124 times 2, 248. We want 130 times 2, 260. 6 times 6, which is 36. 12 times 6, which is 72. You can check on a calculator. So if we add these all together, we should get 616, which is what we've got over here. So this is just an alternative. but you might find it tidier. It's maybe easier to check. With this, if I made a mistake, it's not very clear how I did it. I'd have to just start again and add them all up. Question 9. You're moving some swords into a new display. Below are the weights of the swords in kilograms. So we've got 1.3 kilograms, 2.1, 1.7, and so on. What's the mean and the range of the weights of the swords? Well, let's start with the mean. Well, the mean is worked out as the total divided by the frequency, or how many. Okay, so the total, we're just going to add them up. 1.3, 2.1, 1.7, 2.4, 0.9, 1.3, 1.5, 1.9, 1.1, 1.3, 2.1, and 2.2. Now doing this is very easy to make a mistake. So if it was in the exam, I would probably do that at least twice to make sure I get the same total each time. So we've got a total of 19.8, and the frequency, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the mean is going to be 19.8 divided by 12, which gives us 1.65, and that was in kilograms. Now we want the range. Well, the range is the biggest minus the smallest. Well, where's the biggest? 2.1, 2.4? Anything bigger than 2.4? No, so that's going to be the biggest and the smallest. We've got 1.3, 0.9, nothing smaller than 0.9. So our range is going to be 2.4 minus 0.9. Which gives us 1.5, and again, that's in kilograms. Okay, question 10. You pick up one of the swords at random. What's the probability that you pick up a sword that weighs more than 2 kilograms? Give your answer as a fraction in its simplest form. Show your working out and write the answer in the box below. Okay. Your probability that you pick up a sword that weighs more than 2 kilograms. Well, we saw before that there were 12 swords. So my denominator is going to be 12. How many weigh more than 2 kilograms? Well, we've got 1, 2, 3, 4. So the probability is going to be 4 out of 12. But they did say, give your answer as a fraction in its simplest form. So this will get you 1 mark, but we need to simplify it down. So we need to say, well, what number goes into both 4 and 12? Well, it's not necessarily the most efficient way, but I know they're both even numbers. So I can divide them both by 2. So we can say, well, 4 divided by 2 is 2. And 12 divided by 2 is 6. Okay, so I've simplified it down. But they can go further because they're still even numbers, so we can divide by 2 again. Well, 2 divided by 2 is going to be 1. And 6 divided by 2 is going to be 3. And certainly now we've got 1 in there, we can't simplify that any further. Okay, question 11. The table below shows the number of visitors to Highfield Castle last week. On Friday, there were 20% more visitors than there were on Thursday. Show your working out and then draw a chart on the graph paper to show the number of visitors during each day last week. Okay, 20% more than on Thursday. Right, well, 20% of Thursday would be 20 over 100 times 150. Because we've got the calculator, I'm going to do it this way. So 20% is 30, and it's 20% more. So we want to add on the original 150, which gives us 180. So that's the only actual calculation we need to do. Now we've got to draw our chart on the graph paper. So we're going to have 5 days and we've got our number of visitors. So it's good to see what the biggest value is. And the biggest value is 195. So we're going to need to make sure our scale goes that high. Right, so here's our graph paper here. I'm going to look at the bottom first of all. So we had 5 days. So we're going to want 5 columns going up. Okay, so maybe if we start from, this is a corner. Let's think, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I want something that's going to split into 5s nicely. So maybe if we stay 15 squares, so 15 divided by 5 means we can have 3 squares for each day. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So it's really important with the graphs that you measure it all out. First, make sure you've got enough space. So this is going to be the days along here. So we've got Monday, Tuesday, Wednesday, Thursday, and Friday. And then we had the scale going up the side. So I think that the highest number we had was 195. So let's see. We've got 10 in each of these boxes. Can we just say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100? Let's see if we've got space for all of this. 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Yeah, so that would just fit in. So we want to go at least as high as the biggest number, which was 195. So we're going slightly beyond it, 200. Now, I don't need to write in every single value between 0 and 200. In fact, what I'm going to do is I'm going to skip and I'm going to say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and carry on like that. 120, 140, 160, 180, and 200. Okay, so now I can draw my line down here for my y-axis. Make sure I label this. So this was our number of visitors. And in fact, I'm going to put a title on it now. So Highfield Castle visitors. And now all we need to do is plot the actual values. Okay, so we've got those values. What have I done with the values? I have them somewhere. Oh, they're over here. Okay, so for Monday we had 165 visitors. So remember, Monday's down here. So we're going to go up to 160. And we've got one little box for each visitor. So 1, 2, 3, 4, 5. So we're going to go across 165. Now the next, for Tuesday we had 195. So here's 190. 195 is going to be up here. For Wednesday we had 135. So here's 140, 120. So 130 would be in the middle. 135 is going to be right here. And then for Thursday we had 150 visitors. So halfway between 140 and 160. And on Friday we had 180. That's the one we worked out. So we're going to go up to here. Draw that across. Okay, so I've just done the tops at the moment. And now I can draw nice straight lines all the way down. You don't have to have your bars touching. but I just think it's more work to have them not touching because you've got to draw more lines. So I would say for ease and simplicity, have your bars touching. Make sure your bars are all the same width though, as we've got here, and that your scale all goes up in the same amount. So here, every one of these boxes is worth 10 all the way down. Okay, so there's our graph. Done. Okay, question 12. You are working for Highfield Roofing. The manager has asked you to calculate the price of a job. The customer has a budget of £1,000. The project will need materials costing £426.93, one roofer and one apprentice for 3 days of work, 8:30 to 12:30. The roofer is paid £84.50 per day. The apprentice is paid £4.75 per hour. Add 20% to the total cost of the job for VAT. Can the project be completed within the budget? Show your working out and write the answer in the box below. Right, so 6 marks here, so we've got quite a lot of work to do. So we've got lots of things to add up, and then we're going to be comparing it to this budget here. So let's have a look. We've got the materials cost. We need to know how much for the individuals. Well, the roofer, he gets paid £84.50 a day, and he's working for 3 days. So we can do £84.50 times 3. And that gives us £253.50. Okay, that's for 3 days. Now for the apprentice, he's paid per hour. So we want to know, well, how many hours is he working? Well, 8:30 to 17:30. We can leave it in the 24-hour clock. And because they're both 30s, we can leave those as they are as well. So 8:30, so let's count up. So it would be 9:30 would be 1 hour, 10:30, 11:30, 12:30, 13:30, 14:30, 15:30, 16:30, 17:30. So that's 9 hours if you can see all of those fingers. So for the apprentice, we want £4.75 times 9, but then also times 3 because he's working 3 days as well. So we've got £4.75 times 9. So that gives him £42.75 per day. Multiplied by 3. It's £128.25p. Right, so we can add these all together now. So we want £426.93, £253.50, and £128.25. So I'll add them up backwards because I've already got that in my calculator. And we get £808.68. Now we also need 20% for VAT. So we can do 20 over 100 times 808.68. In fact, I've got that in there, so I can just do times 20 divided by 100. So we get 161, and we want 2 decimal places, 7 to 3. The 6 is more than the 5, so we're going to round it to 74. So this is our VAT. So we're going to add the VAT onto the previous total. And we'll need to round that again, so 416, so that's going to be 42. So we get a total of 970.42. That's the total cost. It's less than 1,000. So, yes, it can be completed within budget. Question 13. You use a lot of water while working. You're buying some new containers to hold the water that you use. Okay, we've got a picture of a container there. The containers are cuboid. So even though that might not look cuboid, it's cuboid. Okay. They have a base of 32 centimeters by 21 centimeters and are 0.5 meters tall. Okay, so let's draw a cuboid. So we're having a base of 32 centimeters by 21 centimeters, and then it's do it up this way. So it's 0.5 meters tall. Okay. You need enough containers to hold at least 100,000 centimeters cubed of water. Each container costs £6.99. How much will it cost to buy the containers that you need? Right, so nothing to notice on this one again is we've got centimeters, centimeters and meters. So if possible, convert your units straight away so you can get you don't want lots of different units, you just want one unit. Because we've got 2 in centimeters, I'm going to turn this one into centimeters as well. Now I know there's 100 centimeters in a meter, so if we multiply that by 100, we're going to get 50 centimeters. Okay. So we want to know how much water we can fit in one container. So to start with, we're going to work out the volume. And the volume, volume, there you go, is the length times the width times the height. So it's going to be 32 times 21 times 50. 32 times 21 times 50 gives us 33,600 centimeters cubed. Okay, so that's one container. We need enough to hold at least 100,000 centimeters cubed, so we want to know how many of those fit in here. Or in other words, 100,000 divided by 33,600. So I'm going to put that in my memory. So 100,000 divided by memory recall, and we get 2.976 containers. Now, if you try and buy 2.976 containers, they'll say, what? Doesn't make sense. So we will have to buy, we can put need 3 containers. Because 2 wouldn't be enough, so we need to go to the next whole number. Okay, so we want 3 containers, and we know that each container costs £6.99. So that's going to give a total cost of £20.97p. Now we're on to the last question. Question 14. So, you're hired for another job to build the roof on a new football stadium. They give you this plan of the stadium. Okay, so it's good to notice that the roof area is just this bit round the outside, so the roof's for the spectators, not for the pitch itself. And they've given us the stadium dimensions. We've got 175 metres that way by 190 metres there. The pitch dimensions are 105 metres by 70 metres. So that's the pitch. So let's put that on here. So that's 105 metres. And that's 70 metres. The roof will be made up of panels that are 50 centimetres by 50 centimetres. So hopefully you'll spot again, we've got metres there and centimetres here. So we might have to do something about that. How many panels will be needed for the entire roof? Show your working out and write the answer in the box below. Right, so we've got an area question here, but we just want the area around the outside. We don't want this bit in the middle. So what we could do, we could split this up into rectangles and work out the area of each rectangle and add them together. Or we can say, well, actually, what we want is we want the area of the big rectangle, and then we want to take away the area of the smaller rectangle. So if we do that, we can say, well, 190 times 175. In fact, let's start by saying area of a rectangle, just to remind us, is the length times the width. So we've got 190 times 175. So 33,250. And that's going to be meters squared. We don't want this bit in the middle, which is the 105 times 70, which is 7,350. So we're going to take that off. Okay, so we've got 33,250 minus 7,350. We're left with 25,900 meters squared. That's for the roof area. Okay, we need to know how many of these panels are going to fit. But remember, these are in centimetres. Previously, we've converted metres into centimetres because usually it gets rid of decimals, which are easier. But we need everything in metres, really. Everything else is in metres. So what I'm going to do is convert these into metres. So 100 centimetres, 1 metre. So 50, so we're going to do 50 divided by 100 is going to tell us how many metres that is. So it's 0.5 metre by 0.5 of a metre. So if we multiply those together, that gives me 0.25 metres squared. So to know how many panels we'll need, we need to take the roof area, which is the 25,900, and divide it by the area of one panel, which is 0.25. 25,900 divided by 0.25, we get 103,600, and we are now talking panels. So that was another big 6-mark question. And that's the end of the paper. So I hope you liked it. Please subscribe to the channel, like the video, add any comments, and look forward to seeing you again soon. Thank you. Bye.